The universe is unimaginably old, unimaginably large, and filled with more stars than we can count. So here is the disturbing question. If intelligent life can appear even once beyond Earth, why haven't we heard from anyone? No alien message, no unmistakable signal, no spacecraft arriving from the darkness. Just silence. This puzzle is known as the Fermi Paradox, named after physicist Enrico Fermi, who reportedly asked a simple question during a lunchtime conversation. Where is everybody? At first, the question seems easy to answer. Space is far too large. Aliens may exist, but they could be too distant to reach us. That is true. But the paradox becomes more interesting when you consider the age of the universe. Earth is about 4.5 billion years old. The universe is more than 3 times older. If another civilization had appeared millions, or even billions of years before ours, it might have had plenty of time to spread through its galaxy, build enormous technologies, or send signals in every direction. Even traveling far below the speed of light, a determined civilization could potentially explore a large part of the Milky Way over enormous stretches of time. So why don't we see evidence of anyone? The first possibility is also the most straightforward. Intelligent life may be extremely rare. Life itself might be difficult to begin. On Earth, life appeared relatively early once the planet became suitable, but that does not prove the process is easy elsewhere. We still do not know how life first emerged from non-living chemistry. And even if simple life is common, complex life may be rare. On Earth, single-celled organisms dominated for most of the planet's history. Multicellular life arrived much later. Intelligence capable of building radio telescopes and spacecraft appeared only once, as far as we know. Maybe the chain of events required for civilization is extraordinarily unlikely. A planet might need stable conditions, liquid water, useful chemistry, a long-lived star, protection from dangerous cosmic events, and enough time for evolution to continue. A small change at any stage could prevent advanced life from appearing. In that case, the silence is not surprising. We may simply be one of the first civilizations to get this far. But there is another possibility. Civilizations exist, yet we are looking for the wrong thing. When humans imagine aliens, we often picture beings who use radio, build machines, and communicate in ways we would recognize. That assumption may be too narrow. A civilization could communicate using methods we have not discovered. It might use highly focused beams that never point toward Earth. It might send messages in a form our instruments do not identify as artificial. It might live mostly inside virtual environments and have little interest in broadcasting into space. Or perhaps advanced civilizations become quieter, not louder. For a few decades, humanity has accidentally leaked radio and television signals into space. But these signals weaken rapidly with distance, and most are difficult to distinguish from natural background noise. An alien civilization far away might not notice them at all. Even a deliberate message could be easy to miss. The signal might pass Earth when our telescopes are pointed elsewhere. It could arrive at a frequency we are not monitoring. It might be so brief that we never record it. Searching the sky is not like checking a mailbox. We do not know exactly where to look, what to listen for, or when a message might arrive. There is also the problem of timing. Imagine 2 civilizations that exist in the same galaxy but at different moments. One broadcasts for 1,000 years, then disappears. Another develops intelligent life 1,000,000 years later. Their eras never overlap. The universe can contain many civilizations without any 2 of them existing at the same time. This may be especially important because technological societies could have short lifetimes. A civilization might destroy itself through war, exhaust its environment, suffer a biological catastrophe, or create technologies it cannot safely control. This leads to one of the darker ideas connected to the Fermi Paradox, the Great Filter. The Great Filter is a hypothetical obstacle that prevents simple matter from becoming a galaxy-spanning civilization. It could lie behind us, in a difficult step such as the origin of life, or the development of complex cells. Or it could lie ahead of us. If most civilizations reach our level and then collapse, the galaxy would appear quiet, even though intelligent life had emerged many times. The silence would not mean we are alone. It would mean survival is rare. But this idea has an important uncertainty. If we discover evidence that life began independently on another world, that might suggest the origin of life is not the hardest step. If we find complex life elsewhere, the difficult step could be intelligence. And if we detect an ancient technological civilization, that could tell us the Great Filter is not necessarily fatal. The problem is that we do not yet know where the hardest step lies. Another explanation is that advanced civilizations are deliberately avoiding us. This is sometimes called the zoo hypothesis. The idea is that extraterrestrials may know we exist, but choose not to interfere, the way humans might observe animals without giving them smartphones or inviting them into global politics. It sounds like science fiction, and there is no evidence that it is true, but it raises a real question. Would a powerful civilization even want to contact a young, unpredictable species? Human history gives us reasons to be cautious. Contact between societies with enormous technological differences has often been destructive for the less powerful side. An advanced civilization might decide that revealing itself would alter our development, create conflict, or cause more harm than good. There is also a simpler concern. Perhaps we are not interesting. The Milky Way contains hundreds of billions of stars and potentially countless planets. To an ancient civilization, humanity might be like a small colony of insects that has just discovered fire. We may be detectable, but not important enough to contact. And then there is the possibility that alien civilizations do not spread across space at all. We tend to assume that expansion is inevitable, but perhaps advanced societies prioritize efficiency, stability, or inner experience over exploration. Crossing interstellar distances is expensive, dangerous, and slow. A civilization could decide that building a rich artificial world is more rewarding than sending ships to distant planets. The universe may be full of intelligence that has chosen not to shout. Still, the most honest answer is that we do not know. So far, scientists have found no confirmed evidence of extraterrestrial life, intelligent or otherwise. That is not proof that aliens do not exist. It only tells us that after a limited search, we have not yet found convincing evidence. Our search has covered only a tiny fraction of the possible signals, locations, time periods, and technologies that might be involved. The silence is real, but our sample is small. Perhaps alien life is rare. Perhaps intelligent civilizations are brief. Perhaps we are early. Perhaps they are hiding. Perhaps they are everywhere, but communicating in a language we have not learned to recognize. Each answer changes what the silence means. It could be evidence that we are extraordinarily lucky. Or it could simply be the natural result of living in a galaxy where distances are vast and conversations take thousands of years. For now, Earth is the only world we know that has asked the question, and that may be the most important insight of all. The silence does not tell us that we are alone. It tells us that we are responsible for what happens next. If intelligent life is rare, then our existence is precious. If civilizations often destroy themselves, then survival is a challenge we must take seriously. And if the universe is waiting for someone to speak first, humanity may eventually have to decide whether to remain silent or send a message into the dark.